Hello, good morning, students. In the last lecture, we had started to study electronic effects. Under electronic effects, we will study inductive effect, resonance effect, electromeric effect, and hyperconjugation. We had already studied first type of effect given under electronic effects is inductive effect. Now the second type of effect is resonance effect. To study about resonance effect, we must know how to draw resonance structures. So first we will study how to draw resonance structure for different molecules. So for this purpose, here one example is given, that is benzene. We know benzene having molecular formula C6H6, and benzene molecule consists of hexagon with 3 double bonds and 3 single bonds in alternate position. So this is a structure of benzene. Here the actual bond length of single bond is given, it is 154 picometer, and bond length of this double bond, it is given as a 133 picometer. But in the resonance structure, this all bond lengths in the benzene structure, they are identical, they are equal, and this indicates that all bonds present in the benzene ring, they are equivalent, they are identical, having bond length 133, 138 picometer. So the cyclic structure of benzene consists of carbon-carbon single bond and carbon-carbon double bond with bond length. For the single bond, it is 154 picometer, and for double bond length is 133 picometer. But the experimental measurements, actual measurements of the benzene ring, it had suggested that the benzene molecule have regular hexagonal shape, and all 6 carbon atoms have same bond length, and it is 138 picometer, which is intermediate between carbon-carbon single bond and carbon-carbon double bond. This means that all 6 carbon atoms, carbon-carbon bond length in benzene molecule are equivalent, unlike what appears from the single Lewis structure of benzene. So when Lewis structure of compound has 2 or more multiple bonds alternating with single bonds, then it is called as a conjugated system of pi bonds. Again, I will explain what is conjugated system of pi bond. Meaning is a compound containing single and double bonds. Here I will show this is carbon, then single bond, carbon, then double bond, carbon, again single bond, carbon, double bond, carbon, single bond, carbon. So in this molecule, if we consider the carbon-carbon single and double bond in alternate position, so this double bond consists of one sigma bond and one pi bond. Means Pi bonds are present in this system which containing carbon-carbon single and double bond. This is called as a conjugated system of pi bonds. And in such a system, that an atom carrying p orbital attached to multiple bond, for that resonance theory is applicable. This is important. Where resonance theory is applicable, where this a system containing carbon-carbon single bond and double bond in alternate position, that is a conjugated system of pi bond where this resonance theory is applicable. Now, the points given in the resonance theory are, the point number one is the pi electrons in the conjugated system of pi bonds are not localized to a particular pi bond. Means these electrons of the pi bond, they are not fixed. They have no fixed position. So this can be delocalized from one location to other location, one position to other position. That is the meaning of first point in the resonance theory. Then the second point given in the resonance theory is that for a compound having conjugated system of pi bonds, that is alternate single and double bond containing system, then it shows the delocalization of electrons. Delocalization means movement of electrons from one position to another position, and this can be shown by using curved arrows. Here in the structure given below, here carbon carbon single bond, that is carbon number 1 and 2, then 2 and 3 have double bond. Similarly here alternate single and double bonds are present in the benzene ring. Here the electrons of double bond, they are shifted to the single bond position, and this can be shown with curved arrow. This arrow head pointing towards the movement of electron. So these forms, that is in the new structure, this double bond becomes a single bond and single bond becomes a double bond. If you see the position in the structure 1, 1 and 2 carbon, 3 and 4 carbon, and 5 and 6 carbon have single bond. But in the second structure, 1 and 2, 3 and 4 and 5 and 6 carbon have double bonds. This is due to the movement of electrons, pi electrons. That is called as a delocalization of pi electrons, shown with curved arrow. And these structures are called as a resonance structures. They are also called as a contributing structures, or also called as a canonical structures. The two resonance structures of the benzene are shown in this structure in this figure. Third point given in the resonance theory is that the position of carbon atoms in the conjugated system, they are not changed. Only the positions of pi electrons are changed. And that is very important. In the resonance structure, remember this is very important. The positions of carbon atoms that remains the same. Only the positions of pi electrons, they are changed. They are moved from one carbon or one bond location to other bond location. Then fourth point given in the resonance theory is that all these resonance structures, they are hypothetical. Real structure is only one, and all these structures written by the difference in the electrons, pi electrons, these are called as a hypothetical structure. Again, remember that while explaining the properties of particular compound, the properties of all resonance form are considered, and that all properties they are present in the real molecule or the actual molecule, and this is called as a resonance hybrid. So resonance hybrid consists of all properties of that molecule. How this resonance hybrid structure of benzene molecule can be written? Here it is a regular hexagon. Instead of double bonds at alternate position, here the dotted line in the circular form, it is shown in the structure of benzene, and this structure is called as a resonance hybrid structure. Now, hypothetical fifth point given in the resonance theory is hypothetical energy of individual resonance structure can be calculated using bond energy values. The energy of actual molecule is lower than that of the resonance structure. In order to resonance hybrid, it is more stable than any of the resonance structures, and resonance stabilization energy is the resonance energy, that is the energy corresponds to actual molecule. So these are the points given in the resonance theory. Now we will study how to draw resonance structure. There are some rules given to draw the resonance structures. The first rule is resonance structure can be written only when all atoms involved in the pi conjugated system, they must be present in the same plane. So that molecule must be planar. Then second rule is all the resonance structure must have same number of unpaired electrons. The number of unpaired electrons will not change. First rule is all atoms are in the same plane. Then number of electron pairs, these remains the same. And third is the resonance structure contribute to the resonance hybrid according to energy or stability. The most stable having low energy and the least stable have high energy. The resonance structure contribute to the largely, and thus they are important. So these are the rules given for writing resonance structure. So between the compared resonance structures, that the resonance structure is more stable and therefore important, which has more number of covalent bonds, more number of atoms with duplet or octet of electrons, less separation of charges, and negative charge, if any, or more electronegative atom, and the positive charge which is present on electropositive atom, and more dispersal, that is the separation of charge. So these points are important while writing resonance structures of molecules. Here one example of resonance structure is given. This is H single bond C double bond O single bond O. Here the negative charge is present on oxygen, and that is moved with shown with the help of curved arrow. Again, this double bond in movement is shown on the oxygen atom, other oxygen atom. So the resonance structure 1 and 2, these are for formic acid anion or the formate group. So in this way we can draw different resonance structures for the different molecules by using these rules. And that is about the resonance structures, resonance theory, and the rules for writing resonance structures of molecules. Thank you.